The ability of a chemical system to do work against its environment is termed energy. For chemical reactions, this energy may be in the form of chemical, light, heat, or sound. Reactions that give off any form of energy are described as exergonic reactions. Those that take in energy are described as endogonic. If the form of energy being measured is heat, the reactions are referred to as exothermic and endothermic, respectively. The study of these energy changes falls under a branch of chemistry called energetics and is formally defined as the study of energy transformations which results in its flow and storage. The field of energetics is underpinned by the law of conservation of energy, which states that energy cannot be created or destroyed, therefore it changes from one form to another during a chemical reaction. The study of energy changes in chemical systems is predicated on the following. 1. Energy is stored in chemical bonds and conserved during chemical reactions. 2. A chemical reaction is a process which requires energy. When reactions take place, energy is required to break bonds in the reactants. When products are formed during reactions, new bonds are made and energy is released. Note, if stronger bonds formed in the products than are broken in the reactants, heat is released to the surroundings and the reaction is exothermic. If stronger bonds break than are formed, heat is absorbed from the surroundings and the reaction is endothermic. 3. Energy can be converted to other forms. When a reaction occurs, the energy stored in the bonds is sometimes released as heat, sound, or light, depending on the reaction. Chemical reactions that result in the increase in temperature of the surroundings are referred to as exothermic, and this net release of heat energy results in the energy of the reaction products being lower than that of the reactants. Instances of this are neutralization and combustion reactions. For example, the combustion of methane to produce carbon dioxide and water is exothermic, as water and carbon dioxide contain stronger bonds than the reactants. Chemical reactions that result in a decrease in temperature of the surroundings are referred to as endothermic. This net gain of heat energy results in the energy of the reactants being lower than that of the products. An example of this is dissolving sodium thiosulfate in water. The sodium and thiosulfate ions in the crystals dissociate and form bonds with water molecules. These bonds are much weaker than the ionic bonds of the crystals, hence the dissolution is endothermic. When a reaction occurs, the bonds of the reactants are first broken to form individual ions or atoms. These individual ions or atoms regroup to form new bonds, making new products or compounds. These two processes occur simultaneously, as often an intermediate known as an activated complex forms in the transition state of the reaction and consists of partially broken bonds of the reactant and partially formed bonds of the product. Enthalpy is a measure of the heat content of a chemical system due to the potential energy of its chemical bonds and other form of internal energy, and is represented by the letter H. Enthalpy cannot be measured directly, and it is the difference in enthalpy between products and reactants that is generally measured. This difference is called the enthalpy change of reaction and is represented by the symbol delta H. The enthalpy change is the amount of heat released or absorbed when a chemical reaction occurs at constant pressure. For most elementary work in chemistry, the terms energy and enthalpy are used as synonyms. However, technically they are not.